Hello everyone, my name is Krishnendu Paul. I am from BuildTech Consultancy and I am doing this video as a part of the final assignment of Seismic Design course from Skyfi Labs. The Seismic Design online video tutorials from Skyfi Labs was used to complete this project. So in this video, we will create this seismic load and we will apply the seismic load on buildings which was set previously. So I have to open this previously set file, and now we will create this seismic load. So the seismic load should be defined first. So as we have defined the wind load, so in similar way we will define the seismic load. Now let us go to the define, then load pattern, then here we just have to type the name of the load, seismic, then type of load is seismic, then here you have to select the 11th code, then add new load. So we have to define other parameters in this definition. So go to this modify lateral load. Here we will apply the load from x direction and y direction. So we will select only these two options. Then these values are available in IS 1893 2016, the recent version of this seismic code. Okay, so let us go to this seismic code. So here you can see this city of the location of the building is in Bangalore, so it is in color blue. So the zone will be zone 2. For zone 2 the seismic zone factor is equal to 0.1. okay, so this is 0.1. Now site type. So for site type we have to go to this IS code again. So if you go to this page number 9, you will get this soil type, that is 1, 2 and 3. So as our building is in medium soil, so we'll select this type 2. Okay. So the soil type will be 2. Then importance factor. So let us go to this IS code again. So in table 8, you will get this importance factor. So here you can see the importance factor. So we'll select this all other buildings. Okay. And you can select the higher values also. So one is selected. Then we have to select the response reduction factor. So R, that is also available in IS 1893. So in table 10, you can get the response reduction factor R for building system. So for our building, it is ordinary moment resisting frame. So our R will be 3. Okay, so what is ordinary moment resisting frame and special moment resisting frame? That is available in the beginning of this code. You can use this code. So R equal to 3 is selected. So okay, we will not change other things. Click on OK. Okay, click on OK again. Now we have to define the load combination. Okay, so load combination is available in define menu. So go to this load combination. Then this load combination is already defined here. So these are including these wind loads. So we can delete this load combination. Okay. Then we'll assign again config frame design. Okay, click on OK. Click on OK. Now we will run this model based on this seismic load, dead load and live load. So we'll go to this analyze option, then load cases to run. Then as we have defined this wind load, but we don't want to run this wind load, so we'll select this run do not run case. Okay, so you can see that this option has been changed. So all the other load cases will be run on this model. So click on run now. So the model will be analyzed. You can see the progress of this analysis here in this left corner, left bottom corner. Wait for some time while this tab finishes the analysis. So now you can see that the analysis is complete, and if you take your mouse cursor on any element, it will show you the displacement, and you can also see the bending moment diagram and shear force diagram here on this display options. So go to this force stress diagram, then this frame, then for shear force diagram click on shear to apply. So this is the shear force diagram. For bending moment diagram you can select this moment 3, click on apply. So this is the bending moment diagram. Okay, so click on OK. Now you can print this result of this analysis from this report menu. Okay. And now we will design this model or the frames based on this seismic load and dead load and live load. So go to this design, steel frame, concrete frame design, and go to this device references. So let us see that this IS code is IS456. Okay, click on OK. Now you can design. So click on design, concrete frame design, then start design and check. So ETAB is running the design. Click on OK. So it will take time. So let us fast forward this video. So it is again showing that 7 concrete frames have been failed. So we have to reiterate this. Click on yes. So it will again run this module. Okay, so it will take time. So we will again fast forward this video. As you can see that 7 concrete frames have been failed, so we have to run again. So we've been running this analysis for 3 times. Okay, so I suppose these sections which are available that are not sufficient, so we have to unlock this model and define another cross sections for each column which will have that cross section property. So in this way we can run this model again, this analysis and this design model. Okay, so we'll select this no here. Okay, click on yes. So this design for this frame members is given by data. So here you can see the reinforcement area for each and every member, bottom and top reinforcement, and for column you can see the area of the reinforcement required. Okay, and you can get this all the values like shear force, bending moment, and this reinforcement in the format of PDF from this option. Okay, so select this project report, double click this option. So it will give you the PDF of this total project. So this PDF is created where you can see all the required values, required properties in the format of report. Okay, you can print this report. Okay, so in our next part of this video, we will apply the response spectrum method for seismic analysis, and on third part of this video, we will apply the chemistry method for seismic analysis. We have to unlock this model for applying this response spectrum method. Okay. Now we have to define this response spectrum method the same manner. So let us go to this load patterns. So as we have seen that this load pattern is defined already, and the modified load patterns here we don't need to change anything. So click on OK just, and then click on OK. Then we have to define this load function or the function for the response spectrum. So here go to this define function and response spectrum. Then here you have to select the IS code, that is IS 2016. Then add new function. Then here give it a name, response spectrum. Then damping is 5%, so it is okay. So seismic zone is 2, as we have already seen. Importance factor is 1 and soil type is 2, as we have already defined in the first part of this video. So it is 3. Okay, so click on OK now. So click on OK again. Now we have to define this load case. So go to this define, then this load case. Then here you have to define this load case, including this response spectrum function. So earlier it was linear static method. So here we have to assign, or we have to create this load case based on this response spectrum method function. So go to this add new case. So give a name. So here you have to select this response spectrum, and here click on add. So we will put the value of this acceleration, and this function will be this response spectrum, and here it will be I into G by 2R. So it will be 1633.5. Okay, so U1 is basically for x-axis. So again we have to add this response spectrum for y-axis. So we'll click on add. Then again here you have to select U2 for the y direction, and here you have to select this response spectrum, and here again this value will be 1633.5. It is nothing but I into G by 2R. I is importance factor, G is acceleration due to gravity, and R is reduction factor. Okay, response reduction factor. So click on OK. Click on OK again. Here we have to check one more thing, the unit of acceleration. So it should be in millimeter per second square. So before creating this load case we should check that. So let us check it now. If it is not okay, then we will again delete that load case and again create this load case again. Okay, so display units. So here you can see the acceleration. Okay, here you can see acceleration unit is millimeter per second square, so it is okay. So we don't need to change that what we have created. So now we have to define the load combination. Go to this load combination. So here you see these things, we can delete this, delete combos, again add default combos. So concrete frame design, click on OK. So it will be created based on these load cases. So click on OK. Now we have to run this model. So before going to analyze, check the load cases which are to be run. So here as instructed, this live load will not be run, so we will not run this dead load too. and other thing will run. Okay, so click on run now. So the software will automatically run this analysis, so it will take time. You can see the progress here. So the analysis is complete. Now if we take this mouse pointer above this structural element, so it will show you the displacement of different points in different directions, and we can see the bending moment diagram and shear force diagram. And based on this analysis we will run the design now. So go to this design menu and then concrete frame design. So this code is IS456 already uh, set in this model. So go to this start design and check. So the software will automatically design the structured element that like beam and column. So it for the design. So here you can see that 8 concrete frames have not been satisfied with this first section. So you have to reiterate this analysis and design. So click on yes. So again it will run this design. We can see that optimizing concrete auto select properties. So where we have assigned, we created these three element, three section for beam and three section for column. So this program is optimizing this section. That means it is trying to provide the lesser cross section. It means the section which has less area, okay, to pass the design, and if it pass then it will show you that design. If it fails then it will say that it is failing, and then it will ask you permission for assigning the higher element. So it has given the design after one iteration, and we can see the cross section, that means cross sectional area of the reinforcement, the bottom reinforcement and top reinforcement in the beam, and in case of column you can see the reinforcement area required. So again we can print this report, print this data as a report as we have created in the last part. So if you can go to this file menu and go to this create report. So here from these options you can create these reports. Now uh, now we will define the time history method, and also based on the time history method we will run the seismic analysis. So go to define, then again function, then time history. So here we have to define this time history function which will be applied on that build. So here go to this from file and click on add new function. So give it a name, time history. Then we import a file of Bhuj earthquake. So similar earthquake motion will be applied on that building to see the responses of the building. So click on browse. So here we will select this file, click on open, and here uh, you can see, okay, the file is uploading in the function. So here you can see the header lines to skip. So here, to understand this, go to this view file. So you can see from 1 2 3 4 5 6 7 8 9. So 9 lines should be uh, avoided. So these lines are header lines. So the actual earthquake values data which will be useful, that is starting from this line. So the starting from the starting line 1 2 3 4 5 6 7 8 9 9 lines should be the header. That means we have to skip this, put the value of 1 here. Okay, click on fixed format. So this is the motion from the Burj earthquake. Click on OK again. So click on OK. So now we will define this load case. So here, as we are going to use this time history data as an input in dynamic analysis, so we'll delete this. So click on add new case. So click give a name. Then here time history. Then do not change this. Click on add. Click on acceleration. So U1 default is time history. It is the 1633.5. So as the data file which we have used this as a input for the time history function that has on data for only x direction, so we will not create any acceleration for the y direction here. Okay, so click on OK. Click on OK. Now again we have to analyze this model. So before analyzing, click on unlock. Okay, then go to this analyze, then load cases to run. So here we will run this model for the time history method only. Okay, and so that's why we have these turned off these options. So now click on run now. So the model will be analyzed by this software. So we have to wait for the completion of this analysis. So we can see that the analysis is complete. Then here you can see the deflection or displacement of any point. Then again we can see the bending moment diagram and shear force diagram. Okay, now we'll design this structure. So go to this design, concrete frame design, then start design and check. Click on OK. So the software will automatically optimize the members. So we have to wait again. So here we can see that the design is complete. So we will get the reinforcement data from this diagram, or we can print this reinforcement data as a project report. So thus in this way we can apply this seismic load, linear static load, and the dynamic load, that means the time history method and this response spectrum method. There are some guidelines in IS 1893 to use these methods, when we should go for this dynamic analysis and when should we go for the static analysis. So we should read that 1893 for better understanding of this application of these different methods. Thank you for watching.